Last time we pretended a vector was just an arrow. That was convenient, visual, and suspiciously pleasant. Today we ruin that simplicity by becoming precise. The point was never that vectors must look like arrows. The point is that we have some objects. We can add them, we can scale them, and the operations behave properly. It is a very mathematical way of saying the rules should not be nonsense. One detail we skipped before: scalars do not come from nowhere. They come from a field. If abstract algebra is not your thing yet, relax. For now, take the field to be the real numbers or the complex numbers. Then continue enjoying your life, briefly, before the notation returns. Here is the official definition. I will not read it line by line like a ceremonial chant for notation enthusiasts. Instead, let us translate it into normal human language. The axioms on the left say vector addition behaves like addition should. It is commutative, associative, there is a zero vector, and every vector has an additive inverse. In other words, adding vectors is not allowed to behave like a badly written bug report. The axioms on the right explain scalar multiplication. Nested scaling must agree with multiplying scalars first. Multiplying by 1 changes nothing. And scalar multiplication distributes over both vector addition and scalar addition. So yes, everything is expected to cooperate like civilized algebra. Now we show some examples. Because definition without examples is a way to make people question their education choices. The standard example is Rn. These are ordinary coordinate vectors. So yes, the familiar arrows were not a lie. They were just a small corner of the story, which is how mathematics likes to begin its betrayals. Vectors do not have to be arrows or coordinate columns. Polynomials also form a vector space, because you can add them and scale them without the universe collapsing. Matrices work as well, and so do continuous functions. At this point, vector really means any kind of object with sensible addition and scalar multiplication. The arrow picture was merely the gateway drug. Whenever mathematicians define a structure, they then spend time proving that obvious things are actually true. Not because they enjoy suffering, although sometimes the evidence is mixed, but because rigor matters. To prove the zero vector is unique, suppose there are 2 zero vectors. Call them 0 and 0 prime. Then 0 equals 0 plus 0 prime, because 0 prime does nothing. But 0 plus 0 prime also equals 0 prime, because 0 does nothing. Therefore they must be equal. One line, no drama, and yet entirely necessary. Here are more of these obvious-looking facts, which I leave to you as exercises. Apparently mathematics is a group project with your future self.